Welcome back to Golang for Devs. Today I'm covering pointers in Go. Now you're probably already familiar with pointers from other languages, but briefly, they are just variables that hold a reference to another value. So they point to another value. They're pretty straightforward in Go, so I'll try to get through this one quickly, but make sure you stick around to the end for a common gotcha that you'll probably mess up otherwise. All right, let's get to it. First up is creating pointers. So let's say I have an int variable that I want a pointer to. I can specify that a type is a pointer by putting a star in front of the type. Then I can get a pointer to a variable using an ampersand like that. The ampersand means that you are taking the address in memory of the variable. You can also get a pointer to a pointer like this. And you can keep doing that, but going past 2 levels deep is mostly pointless. Go also has a built-in new function that you can use to create a pointer for a specific type. So this will give you a pointer to an int. And when you use the new function, the actual value is instantiated with the 0 value for the type. So in this case, it would be 0. And the 0 value of any type of pointer is always going to be nil. Okay, next up, you can get the actual value from a pointer using similar star syntax. So if I have an int and a pointer to that int, I can go backwards from the pointer to get the original value of the int using a star. It's a little confusing that both dereferencing and declaring variables uses a star, but them's the breaks. So those are the very basics of using pointers in Go, but it's 100% worth noting that there are a number of non-addressable expressions that you can't use an ampersand with to create a pointer. So first up, you can't take the address with an ampersand of a constant. So this will result in a compiler error. The same is true for basic literal types. So you can't directly get a pointer to a literal number or a literal string. Then there's a general rule that you can't take the address of an operation. So this applies to things like numeric expressions, calling functions, and type conversion. So all of these examples would result in a compiler error. To get around these errors, you can use an intermediary variable. So if I wanted to fix the function example, I would first store a result from calling the function, and then take that result and get a pointer to it. So this one works. Okay, next up, just to cover it very briefly, you can specify that a function is expecting a pointer argument using the star syntax. Then when you call your function, you can use an ampersand directly to address your variable inside the function call, like so. Okay, last thing I wanted to cover is the gotcha that I mentioned at the start of the video. But before that, don't forget to like and subscribe if you're finding this series helpful and want to see more. Okay, so the gotcha has to do with how the Go compiler decides where to store a variable in the stack or in the heap. So if I have a function that returns a pointer and there's a local variable, that local variable will generally live in the stack. But if I return a pointer to that variable, the pointer can't point at a local stack variable that's going to get removed as soon as the function ends. So the compiler needs to escape this variable to the heap. It's not a huge deal if this is a one-off function call, but if you're doing this a lot, it can impact performance. And this pattern is called sharing up. So you don't want to share up. The fix is super simple. Instead of sharing up, we want to share down. So instead of returning a new pointer, this function accepts a pointer as an argument. And then you can dereference that pointer and set the actual value to whatever you want. So when the function returns, you'll have the same result, but it will be much more likely to be stored on the stack instead of the heap. So when you can, always pass pointers down into a function and share down. And that's literally everything you need to know about pointers in Go. If you want to see any of the code from the video, the link is in the description. Thanks for watching, and as always, keep building, keep breathing, and I'll see you next time. Peace out.